Okay, so now we have this example here where it says to write the general term for the geometric sequence. So here all it does is give us our terms, right? 3, 6, 12, 24, and 48. So let's talk about the position of each term. So 3 is my first term, so I can say that's a sub 1. 6 would be a sub 2, and then we just continue on. A sub 5 is 48, all the way to wherever it ends, or continues on to. Then it says, then use the formula for the general term to find the eighth term. Okay, so first we know the formula is a sub n equals the first number, common ratio, n minus 1. Okay. So here they're asking us to find the eighth term, but let's go ahead and just find this first stuff. So a sub 1. My first term in this sequence is 3. Then I have the common ratio of r. So if you recall previously, I said to take the second term and divide it by the first term. So let's write this r equals, let's change this color to something else here. Okay, so r is going to be a sub 2, which is 6, divided by a sub 1, which is 3, which is 2. And just to verify it, I'm going to show you that you could have used the third term and divided by the previous term, which is 6. So a sub 3 divided by a sub 2, and you still get 2. So this shows us that our r value, our common ratio, is actually 2. So if it says write the general term for the geometric sequence, so let's write the formula first. The formula is going to be a sub n is equal to my first term, parentheses, 2 raised to the n minus 1. Now, after we come up with that, it does say to find the eighth term, so I'm going to write n here and find the eighth term. So now we know this is 8. So last, we are going to set this up and solve it. So a sub n is 8. 3 times 2 raised to the 8 minus 1. A sub 8 equals 3 times 2 raised to the 7th. And then once again, just take this, put it in the calculator. So we went to this side here. All right, so we have 3 parentheses 2 close parentheses raised to the 7th power, and we get 384.